Now let's explore the wired equivalent privacy, the WEP protocol. Sometimes it is misinterpreted as the wireless encryption protocol, but the exact interpretation is wired equivalent privacy. Let's review some of the concepts about the wireless network security. The wireless networks are more problematic regarding the security issues than the wired networks. Because of the open transmission media, the transmission media is the air, and the air is open for everyone to sniff, is open for everyone to capture the traffic and start attacking, is open for everyone in the area covered to send and receive messages through the air to the transmission and the connecting devices in a wireless network. So it is more problematic and more difficult, and let us say that most of the time of the security officer will be spent on two issues: securing the servers and securing the wireless network. Your headache as a security specialist will come from two sources: your servers, your demilitarized zone, especially the webmail DNS servers. Those will be the hot spots of your attack, and the wireless network that will convey and include most of the guests, most of the people that you are not controlling, most of the people that are visitors to your premises or to your organization, and you don't know much about them and about their security setup. So they will be a source of attack, and they will be something that you should take care of and isolate from your wired network. So this open transmission media is susceptible for sniffing. The wide area of coverage is not always an advantage for the wireless networks. Sometimes wide area of coverage leads to more problems in the wireless network. Sometimes people tend to buy more stronger antenna and try to let the coverage area be greater, as great as possible, and maximize the coverage area of the wireless network. This is not always in the advantage of security, because sometimes this area exceeds the limits of the premises itself, exceeds the limits of the organization of the building itself, and tends to be around the building itself to the cars and the people passing the street around the building itself. So you are not controlling who is accessing your access point, who is in reach of your wireless network. So this can be a point that you must take care of, and you must know for how distant your wireless network is reaching. The higher bit error rate, this is something by the nature of communications, of wireless communications. It has high bit error rate than the wired network. This is something that is unwanted, but it is accepted in regard to the flexibility and mobility and the so much advantages of the wired network. Sometimes you need to isolate your wireless network from your sensitive data. Isolate your wireless network from your servers, your precious servers, your sensitive data and information. This isolation is done through placing a firewall, for example, or placing some VLAN separation, or placing them through separate physical switches. And this isolation is needed because you need to separate a vector of attackers that may exist on the wireless network from your sensitive and precious information that are on your wired infrastructure. So you may need, as a security officer, to think of the way of separation that you will follow. Sometimes you require encryption in transient. In transient of transmission of the data is in the air. So how would you protect it? Sometimes you may think of encrypting the data. What is meant by encryption we will see in the next slide. But encryption makes the data, keeps the confidentiality of the data, makes the data hard to be read and to be captured and to be interpreted. It can be captured in an encrypted form, so it is useless. It looks like ciphertext, not plain text, and at the same time it is having the advantage of flexibility and mobility of the wireless network, and at the same time it is keeping its confidentiality. Let's have a look at the word encryption. What is meant by encryption? Encryption is the process of encoding a message or information. What is encoding? Encoding is letting the message transfer from the form of plain text to the form of ciphertext. So only authorized parties can access this information. Why? Because only authorized parties can decrypt the data and return the data to its original form from ciphertext to plain text once again. There is a science, a very big science, that's called cryptography, where much mathematics is involved. That you can, cryptography is the way how to encrypt and how to decrypt and how to use the keys of encryption, decryption, and the ways. And this is a very big science that uses the binary mathematics and specifies the ways of encryption and decryption for the data. Decryption is the reverse process of encryption. Decryption is transferring the data once more from ciphertext that cannot be read into data. Let's have a look at this diagram. You can see the word hello. Hello, after being encrypted, is transferred in something in the middle that has no meaning, that if read by any person does not mean to him anything. But after passing again to the decryption key, it returns to the word hello. So the left is encryption and the right is the decryption, and in between we have just ciphertext that cannot be read by anyone. So only the authorized parties here, according to this diagram, has access to the right information and can read the word hello. We have encryption that transfers data into cipher, we have decryption that transfers cipher into data, and we have the key of encryption. The key of encryption can be a sequence of ones or zeros. The longer the key, the harder to be broken. The longer the key, the harder this encryption algorithm gets, and the harder this encryption algorithm is against breaking and against decryption as well. So the key can be a sequence of ones and zeros that can be, for example, 8 bits long or 16 bits long. That can be hard for guessing, and that can be used for encryption, and the same key sometimes is used for decryption if the encryption is symmetric or something like this, and some other times the key of encryption is different than the key of decryption in asymmetric encryption algorithms. This is a very brief introduction about the word encryption. Let's see here the wired equivalent privacy, the WEP, as an encryption protocol for wireless networks. It was built to suit the IEEE 800 and 2.11, which is the Wi-Fi standard. It was targeting preserving the confidentiality of data, not breaking the confidentiality of data. It used a key that is 10 to 26 hexadecimal digits, which means that it is 40 to 104 bits in length. So it is long enough to be good for some time. It included the methods for encryption data using a shared secret and the RC4 encryption algorithm. This is a very well-known encryption algorithm, a strong one that has been well known for a long time and that has been defending breaking and defending being broken by any attacker for a long time. But now it is not advisable to use the WEP. At one time the WEP was widely used. At some time WEP was the main encryption protocol for all the wireless networks until it has been broken and it has been announced superseded. We have some drawbacks of the WEP. Shared secrets that are used, the shared keys that are used, the shared secrets that are used in encryption and decryption do not remain secretive. It is shared among some people, so it may be shared among attackers as well. The WEP has inability to rotate the WEP keys. Rotating the WEP keys make the encryption algorithm stronger, and this inability makes the WEP stagnant. So produce the stagnant shared secret implementations has led the WEP to be easily broken and to be easily intruded by attackers. Accelerated web cracking becoming common. So you can search the internet about cracking the WEP. You would reach many softwares and many videos on many websites that can explain step by step how can you break and read and access any wireless network using the WEP encryption algorithm to encrypt its data. So in 2003, the Wi-Fi Alliance announced that WEP had been superseded. And we here in this course advise and recommend you do not use WEP as your encryption algorithm. Even if it is existing among your options, eliminate it from your choices, eliminate it from your options, and do not use WEP as the encryption algorithm for wireless networks. We have other promising encryption algorithms for the wireless network that we are going to introduce in the coming slides. Thank you.